Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we are focusing on ISS 2026. We have completed one of the major topics in statistics paper 3 which is econometrics, and we have started with sampling techniques in which we have covered the topics simple random sampling with and without replacement, stratified random sampling, and systematic random sampling. We have covered ratio estimator, product estimator, and today we will continue with another kind of estimator, which is regression estimator. So let us begin. Now we know that ratio estimator is used whenever ratio estimator fails with respect to simple random sampling. It is more efficient than when simple random sampling is more efficient than ratio estimator. Then we use product estimator. But what if it is less efficient with respect to this? Because ratio estimator is used for regress regression line regression of y on x. It is used for this purpose, where this regression line is linear plus it passes through origin. In this scenario, we use ratio estimator. But what happens if this regression of y on x is linear? Obviously, the regression line is always linear, but it doesn't passes through origin. Then we use regression estimator. Regression estimator is estimation is best for when regression line do not pass through origin. In this scenario, we use regression estimator. Now, we define regression estimator by this. Regression estimator can be defined as y bar cap small r. Capital R we used for ratio estimator, P we used for product estimator, and small r we are using for regression estimator. It is nothing but y bar, which is population mean, plus theta into x bar minus small x bar, or we can write it vice versa, small x bar minus capital X bar. Now here, what is c? Theta is any constant. X is auxiliary variable and y is study variable. And y bar small r is regression estimator. So this is the equation of regression estimator. Now we'll first find out what is the variance. What is the estimation of this unbiasedness? For unbiasedness, we will take estimation of y mean of regression estimator is equals to estimation of capital Y bar plus theta into small x bar minus capital X bar. Now we know that estimation of population mean is population mean only, so it will be y bar. Then theta is constant, it will come out, and we are left with estimation of small x bar, and estimation of capital X bar is capital X bar only. So this will become y bar plus theta. From simple random sampling without replacement, estimation of sample mean is equals to population mean. So it will be capital X bar minus capital X bar. This value becomes 0. So our estimation of mean of regression estimator is equals to population mean, and hence we can say that mean of regression estimator is an unbiased estimator of population mean. Y bar, right? So it is unbiased estimator, we have proved. Now first of all we have to find the value of theta in order to get the variance. So for the value of theta we know that variance of variance of regression estimator should be minimum. For this should be minimum, we will first of all write the variance of y bar r, which is nothing but variance of y bar plus theta small x bar minus capital X bar. So it will be nothing but variance of y bar plus theta into variance of x bar minus 2 theta covariance of y bar in and x bar. So here we can this is the variance of y cap regression estimator. We will differentiate it for it to be minimum. We will differentiate this with respect to theta. When I differentiate it with respect to theta, it will be 0. When I differentiate with it with respect to theta, it will be variance of x bar. And when I differentiate it with respect to theta, it will be 2 into covariance of x bar into x bar and y bar. And then this is the normal equation. We will put this equals to 0. If I put this equals to 0, we will get, this is theta square. So it will be 2 theta. We will get theta is equals to covariance of x bar y bar. This sign will be plus, so it will be minus upon variance of x bar. Covariance of x bar y bar is nothing but sxy, and covariance of x bar is nothing but sx square. So this can be written as, let us suppose that this is nothing but equal to beta. So theta is sxy upon sx square, which is equals to beta. Let. So now our regression estimator becomes y bar plus theta. Instead of theta, I can write sxy, and it will be minus, because it was minus sx y with a minus sign. So minus sxy upon sx square into small x bar minus capital X bar. This can be written as y bar minus, let us take it equal to beta, and small x bar minus capital X bar. Thus we can write it as y bar plus beta capital X bar minus small x bar. I have taken minus common from here, and therefore the sign became plus. So it will be the value of regression estimator. where beta is nothing but sxy upon sx square. So we have calculated the value of y cap r, where beta is always greater than 0. Now the variance of regression estimator can be calculated as variance of regression estimator is variance of y bar cap r is equals to variance of y bar plus beta square variance of x bar plus 2 covariance of y bar into x bar and into beta. Variance of y bar, we know that it is nothing but sy square upon y bar square into f by n. Due to simple random sampling without replacement, the variance comes out to be this. If you are not understanding the logic behind this, then we have done in the first lecture of ratio estimator whole derivation how this comes, so you can rewatch that in order to be clarified on this. So this came from that, and this is beta square into f by n into sx square upon x bar square plus 2 into beta. Covariance of x bar and y bar is nothing but sx bar. So this can be written as f by n comes out to be common, and we are left with sy square upon y bar square plus sx square upon x bar square into beta square plus 2 into beta sxy upon, this is also f by n, x bar into y bar. This can further be written as f by n into y bar square cy square plus beta square cx square plus 2 beta cx cy. So this is the derivation of variance of regression estimator. Now we will do the comparison between regression estimator and that. Regression estimator and simple random sampling without replacement. So comparison between regression estimator and simple random sampling without replacement. We know that variance of y bar simple random sampling without replacement is nothing but n minus n upon n into y bar square upon, okay, let us take that, sy square upon small n. We can multiply and divide by y bar square. Now this term, this upon this, it becomes what? It becomes equal to cy square, and this is equals to f. So it will be small f upon n into y bar square to cy square. And variance of regression estimator we have calculated, which is nothing but this. So we will subtract variance of mean of regression estimator minus variance of mean of simple random sample without replacement can be written as, let us take it on Next page. This can be written as f by n into capital Y bar square cx square cy square plus beta square cx square plus 2 beta cx cy minus f by n y bar square into cy square. So this whole term and this term gets cancelled, and we are left with variance of mean of regression estimator minus variance of simple random sampling without replacement is nothing but f by n to y bar square cx bracket beta square cx. Okay, we can take beta also common outside. Beta cx plus 2cy. Now if this beta cx plus 2cy is greater than 0, if beta cx plus 2cy is less than 0, if beta cx plus 2cy is equals to 0, then if it is greater than 0, then simple random sampling without replacement is more efficient than regression estimator. If this is less than 0, then regression estimator is more efficient than simple random sampling without replacement. If it is equals to 0, then both are equally efficient. Okay, so this was the comparison. There is one more case in this regression estimator. Case 1 and case 2. Case 1 says that if beta is equals to beta naught is known, if beta is known priorly, then we can say our regression estimator, mean of regression estimator is nothing but y bar plus beta naught capital X bar minus small x bar, where beta naught is greater than 0. And case 2, if beta is unknown, when beta is unknown, we can say that mean of regression estimator is equals to y bar plus beta capital X bar minus small x bar, which is nothing but beta is greater than 0. So these are the two cases which arises depending on the value of beta, if it is known priorly or unknown. Further on this, we have discussed case 1 today. When beta is known, you can rewrite this. You can rewrite this beta naught for beta known, for beta known, beta naught, beta naught, beta naught. You can just skip it, or you can say beta is known value of beta simply. And case 2, which is unknown case, we'll discuss it tomorrow. I hope you got what we have done today in the class. All of Keep on working hard with consistency. I'm telling you this again and again, and you should focus on what we are doing in class and do the revision daily with the class and after the class as well, so as to improve yourself, because in this exam it needs a lot of hard work, and consistency is the key to success. We all know that, but how much we are focusing on that. So focus on consistency and hard work, and keep on watching the lecture videos. Along with this, English classes of idioms and phrases are also going on. They'll be completed soon, and after that Vibhuti ma'am will be starting a new topic, so we should focus along with this to that as well. So keep on working hard again and again. I'm telling you this. All the best. Thank you.